In this video, we're going to talk about threaded inserts. Let's type that in here and get a visual for what we're talking about. Oops. There we go. Threaded inserts. Here's a very common style. The trade name for this particular one, this is called out as a helical insert. That's a general description for it, but there's a trade name that is very common you'll hear in the industry that's called helicoils, H-E-L-I-C-O-I-L, helicoil, or helicoils, plural. And these are, like I said, one of the most common types of threaded inserts that are used. Taking a step back a little bit, higher level, a threaded insert is well, it's an insert that can be installed into most materials, certainly into metals and plastics, and sometimes even wood. But as a mechanical designer, you'll mostly be focused on metals and plastics. And especially when you're using plastics, threading a plastic part directly produces plastic threads. And just due to the nature of plastic part properties or plastic material properties, those threads are not terribly strong or robust, and they can get damaged or wear out. And so the solution to that is to use a steel threaded insert, or sometimes they're not steel, brass is another common material for a threaded insert. And you install these inserts into your part geometry, and you're able to take advantage of, maybe you want to use plastic as your parts property because of plastic is a lightweight material, and maybe you don't need a ton of strength in this material, or maybe you're just trying to keep the weight down. It's probably cheaper to make this part out of plastic than metal. So for whatever reason you want to use plastic for your part, you can still get really strong threads by putting a threaded insert into your part. Okay, so threaded inserts come in a vast array of different thread types. You can see here all the same machine threads that you would see in a fastener. You know, 256, 440, 448, 632, 1024, quarter 20, all the typical machine thread sizes and pitches are there. Let's see. Often threaded inserts are used in aluminum, especially when you're using stainless steel fasteners. Stainless steel fasteners have a bad habit of what's called galling on aluminum threads. Galling, we won't get too far into it, but it's basically a welding of the steel fastener onto the aluminum thread, and it occurs it occurs in threads. Galling is a term used in reference to a fastener that basically gets fused or welded to the thread it's screwing into, and certain material combinations will facilitate galling more than others, like aluminum. Aluminum threads on stainless steel fastener is a bad combination, and we always try to avoid that. Not to say that it will gall, but it has a higher likelihood or possibility of galling. So when we have aluminum parts and we have threaded holes in them, we will often, not always, but often put threaded inserts in there. It takes a little bit more time, and it makes the design a little bit more expensive, but if this is something that you're going to be taking fasteners in and out of many times, then it makes sense to spend a little bit more and put some threaded inserts in there. These threaded inserts are, I mean, this one right here is 18/8 stainless steel, so stainless steel thread on a stainless steel fastener is less likely to gall. Anyway, that's why we might use a threaded insert. Maybe we can poke around here a little bit more. There are a few different types of these. We're just looking at the helicoil style right now, or the helical insert. One that we use fairly often is a locking style helical insert. So this is a lubricated version of the locking style, And this one right here is just a plain locking style without any lubrication. The lubrication further reduces the chance that you'll see galling. But you can kind of see right here that there's this almost like hexagonal element or winding within the helical insert, and that hex shape there creates a little bit of interference with your fastener when your fastener is screwed in, and it just reduces the chance that your fastener will back out unintentionally over time, because there's a little bit of friction preventing it from turning out of the thread. These helicoils do require a special installation tool, and so if you don't have that tool, you will not be able to install these. Let's look at another kind of threaded insert. Let's see, I wonder if it'll... Threaded inserts, nuts, anchors. Here we go. So there are varieties that are used in plastic. Let's see if we can select materials: aluminum, brass, titanium. Oh, that's probably the material of the insert itself. I wonder if they have a filter in here used on... No, I don't see anything. Oh, here we go, for use in plastic. Okay, so these brass threaded inserts are very common. They've got kind of a slit in one end so that the brass actually will contract around the barrel and expand. So you press these into a fairly tight toleranced hole, and the two sides of that barrel will kind of flex in because of that slot that runs down the center. And so the barrel will kind of compress a little bit and allow you to push this insert into your material. These are commonly used in plastic especially. And then once you insert your screw from the top over here, that will kind of expand these the sides of the barrel outwards into your material. And these the outer faces of these inserts are knurled. It's a really rough texture that's created in the parts, and so that knurled rough texture will kind of sink its teeth into the hole that into which these have been pressed. And that happens when you screw your fastener in. You know, the fastener kind of pushes those wings of the barrel out, and then the knurled teeth sink into the material of your base, your part. So these are brass threaded inserts, another really common style. One other style we can look at are these heat set inserts for plastics, and these are pretty cool parts. Once you have a pilot hole in your plastic, what you can do is take like a soldering iron, and the tip of that soldering iron you can place at the mouth of this insert, and the bottom of the insert down over here would be placed at the beginning of the hole in your plastic part. And when you push, you plug your solder iron in, and you push on this opening, and the soldering iron heats up, and that heat is transferred through the part. These parts are often brass, and brass is an excellent conductor of heat. So it conducts that heat all the way down to the bottom, and the bottom is contacting the beginning of that hole in your plastic part, which then heats up the plastic, and pretty soon this entire insert will kind of just sink into your plastic part. And then once the plastic, once it's installed, you remove your soldering iron, and then the plastic cools and just kind of solidifies around these almost kind of scalloped or ridged exterior faces, and then that insert is set in there and won't come out. If you found this content helpful, consider enrolling in our signature program at mypipelineacademy.com. Whether you're an individual interested in beginning a new career as a mechanical designer, or a company interested in training your new engineering hires, our signature program helps students develop the practical skills they need to be productive mechanical design engineers. Seating is limited. We hope to see you there soon.